Hey guys, hope you're having a good day. So today what we're going to talk about is solving equations with a variable on both sides. So the last time we talked about solving equations with a variable on one side and they got progressively harder, but now there's going to be a variable, aka a letter, on both sides and we're going to be able to solve it. If you have any questions or anything we've done so far, make sure you're reaching out for help. Miss Sanders or myself are available for you if you need us. Um, Other than that, let's talk about solving equations with a variable on both sides. So, before we do any examples, what I would like to do is kind of just talk about a general rule for these. This is not always going to be the rule, but it is kind of nice to follow these steps. So step one, we're going to say we're going to get rid of our parentheses. Step two, we're going to combine like terms. And then step three, we're going to solve the equation. All right, so if we follow these steps, the first one for this first problem would be to get rid of the parentheses. In order to do that, I had to distribute right here, right? Because that's what this means. That means I am multiplying. So I'm going to distribute this -2 to both of these. So I'm going to rewrite the left-hand side. It's going to say the same. And don't forget, whenever we solve these, I like to draw a line where my equal sign is. So if I'm moving things from one side to the other, I can use a property of equality. But we're going to distribute that -2. So I get -2x plus 8 plus 9. Okay, now we got rid of our parentheses. The next step is to combine like terms. And when I say combine like terms, I mean look on the left side of your line and combine anything you can on that left-hand side. So are there anything that have similar terms or like terms? Well, 3x and 4x are like terms, so I can combine those. So what's 3x plus 4x? Well, that is 7x, and I still have my -10. Now look on the right-hand side of your line. Is there anything I can combine? I can combine the 8 and the 9. So now I have -2x plus 17. All right. Now we go to the third step, solve the equation. Okay, and again, these steps aren't always going to be in this order, not going to be this simple. It doesn't work for every single problem, but this is a general rule that we're going to follow. So now I want to solve the equation. In order to do that, I need to move everything with an x in it on one side and everything that's a number, a constant, to the other side. So what I'm going to do is I really like for my x's to be positive. So I'm going to add this 2x to both sides of the equation. Because when I do that, it cancels right here. And now I have 7x plus 2x, which is 9x, minus 10 equals 17. Okay, and then this kind of turns into what we've been doing before, right? So now if I want to solve for x, I need to add 10 to both sides. So I get 9x equals 27. And then our last step, we're going to divide by 9. Again, my answer is x equals 3. Now the nice thing about this is, can you plug it back in and check it? Well, of course. So anytime I see an x, I'm going to write a 3. So 3 times 3 minus 10 plus 4 times 3 equals -2. 3 minus 4 plus 9. All right? So what I would do would be this first. So I have -2 times -1 plus 9. This is going to be 3 times 3, which is 9. 4 times 3, which is 12. So notice I did parentheses first. I followed my order of operations. There are no exponents. And then I multiplied. And so now I can combine all my terms on this side, and I can multiply here to get a +2. So then I would have 21 minus 10, which should be 11 on both sides. So that means it works. To get the 21, I did 9 plus 12. to give me that 21. And if it equals each other, then I know it's correct. So that is solving an equation with a variable on both sides. All right. So again, following our steps. If you want to pause this and try the problem here, I encourage you to do so. Again, following our steps though, we're going to get rid of parentheses, so I need to distribute. So I have 1/2 n minus 2 minus 7 equals -2n plus 6. All right, next step, I'm going to combine my like terms, so I can combine these two on this left-hand side. And then from there, I'm going to move the variables or the letters to one side and the numbers to the other. I'm going to move my 2n to this left-hand side. Your calculator should be able to do this. It's 2.5 n minus 9 equals 6. Going to add my 9 to the other side. So I get 2.5 n equals 15. Now you're taking that 2.5 and you're multiplying it by n. So what's the opposite of multiplying? Well, that would be division. So I'm going to divide by 2.5. And I get n equals 6. Now can we plug it in and check it? Well, just like we did in the first problem, of course we can. Again, if this was a test or a quiz, I strongly encourage you to check it to make sure it works. So when I check, I get 1/2 times 2 minus 7 equals, instead of writing n, I should have wrote a 2, or 6, sorry. So this would be 1 minus 7 equals -12 plus 6. -6 equals -6. Does that work out? Yes. So my answer is correct. Again, I would definitely check every single problem if you can. All right, what I want you guys to do is I'm going to pause the video here, have you answer these two questions, try them on your own. This is just like what we did in those last two examples. So welcome back. I'm going to work these out now. So remember, general rule, we like to get rid of parentheses, so I'm going to distribute. This time you have to distribute more than once, which is fine. So I'll distribute on the left-hand side. I get 100z minus, type this into your calculator, 100 times 0.2 minus 20 equals -50z minus 8. Okay, from here, I'm going to move my variables to one side, my numbers to the other. I like to take the negative variable and add it to the other side because we didn't have any like terms to combine right on either side. So we can go ahead and move everything over. 150z minus 20 equals -8. And then I'm going to add my 20 over. I get 150z equals 12. Divide by 150. Z equals 12 over 150. Or we can simplify it. I can divide the numerator by 2 and the denominator by 2. I can also divide them by 3 from here on top and bottom. So I divide 6 by 3 and I get 2. I divide 75 by 3 and I get 25. So my final answer would be 2 over 25. If you want to simplify it, I will also take this answer as well though. All right. So that was A. Now let's work through B. Remember, general rule, we like to get rid of our parentheses, so we need to multiply, aka distribute. Draw my line. This is 10d plus 15 equals 6d minus 6 plus 1. All right, so now I need to combine like terms if I can. On this right-hand side, I can combine these two. So I get 6d minus 5, and now we're going to move everything to one side. So I'm going to subtract 6d. I get 4d plus 15 equals negative 5. The reason why I chose to subtract 6d instead of subtracting 10d, which you can do it either way, is because I like for my variable, my letter to be positive. So 10 is bigger than 6. So I'm going to subtract that over. That way I have 4. So when I subtract 15, again, you would type most of this into your calculator as you're going. You get negative 20. You're going to divide by 4, and I get negative 5. And that is solving an equation with two variables on both sides. So those are the most basic examples. So then, let's do another example. We run into something like this. So if I was going to solve this, I need to combine like terms. Sorry, distribute, not combine like terms. I get 4x plus 6. Well, most people could stop right here and say, well, that's the same thing, right? Well, if we keep going, all right, I subtract 4x, subtract 4x. Well, how many x's do I have now? I don't have any, right? So the x's are gone. So I have 6 equals 6. Does 6 equal 6? The answer is yes. So we call this is a special case, we call this an identity. All right? Every identity we've been working with so far has been consistent, independent. And that means you have one answer. When you think about the problems we've done so far, they've all had one answer, right? Like D equals 20, D equals 15, N equals 6, or whatever we did before. Now this one though, because I know 6 equals 6 and there are no x's left, it's called a consistent dependent. So I didn't get an answer like x equals 2, x equals 5, something like that. So consistent dependent means there's infinitely many answers. Because I can plug anything I want in for x and it's going to work. Because they're the same equation on both sides of the equal sign. So the same setup. So like in ours, it was 4x plus 6 equals 4x plus 6. That's called a consistent dependent. And the next one, the last one, it would be an inconsistent system. And we call it inconsistent because it has no solution. And we'll do an example of that. All right? So that's your 3 types of answers. Most of the ones we've done so far have been this, but the one we just did was a consistent dependent, and it has infinitely many answers. Notice it doesn't say x equals 6. It says 6 equals 6. So if they equal each other in a number, you know it's correct. So next example. It says, what is the value of x and 6x minus 5 equals 2 times 3x plus 4? So again, we're going to get rid of our parentheses. We're going to distribute. Okay, and then we're going to move our variables to one side, or we're going to combine like terms. There are no like terms to combine, so now we're going to solve it by subtracting 6x. Well, here's what happens, right? The 6x is canceled, so then I have negative 5 equals 8. Well, does negative 5 equal 8? Hopefully you're saying no, right? So that would be called an inconsistent system, and that means no solution. So this problem has no answer. And you would write no solution as your answer. All right? I want you to try these two right here. Solve each equation. Is the equation identity? Explain. So the first thing, this is a negative 1. Hopefully you pause it and you've attempted this. You would distribute. right? So then I would subtract my t over. I get negative 27 equals negative 27. Well, is that true? Yep. So we're going to call that consistent dependent. And how many answers does that have? Well, if I have a number equals a number, and it's the same number, it's going to be infinitely many. All right. Again, hopefully you've paused this and you've tried B as well. So I'm going to work it out. If you haven't, I encourage you to pause it and try it. On this one, this is a little bit harder. When you distribute this, you would take 96 times m and then divide it by 2. So 96 divided by 2, I get negative 48m plus 96. So when I add my 48m over, these cancel. I get 64 equals 96. Well, is that true? No. So it's going to be inconsistent. And what should your answer be? It should be no solution. All right, so I want you guys to try these. Instead of writing inconsistent, consistent, dependent, I just want you to tell me how many answers it has. If it has one answer, you're going to tell me x equals 2. If it has no solution, you're going to say no solution. If it has infinitely many solutions, you're going to say that. All right, so go ahead and try these 4 problems, and I will work them out and post the answers for these problems. So I'm just going to go ahead and work them out. It's just easier for me to do this. Distribute. So hopefully for number 5, you got x equals 9. So that would be one solution. Number 6, hopefully you got h is negative 2. Make sure you're combining like terms after we distribute. Some people can stop right here and say, well, that's the same equation, right? So how many answers am I going to have? I'm going to have infinitely many solutions. Sometimes they say all real numbers, just so you guys can see that as well. Either one works. All real numbers are infinitely many solutions. Because negative 12 equals negative 12. Now our last one, number 8. Distribute. We get -4 equals -8. We know that doesn't work, so we're going to say no solution. All right, guys. If there's an assignment, we will let you know and I'll post it. Otherwise, if you have any questions or you need some extra help with this, extra practice, I know this is a difficult topic, please let me know and we will set up a time to meet to discuss this. Have a good day, guys.